This is lesson 8-2, factoring out a GCF.
Before factoring out a greatest common factor, we first need to be able to find it. Greatest common factor does not just consist of a number any longer. It consists of a combination of numbers and a variable or multiple variables. The first thing that we want to do when finding a greatest common factor is to find the greatest common factor of the coefficients. From there, you want to take the least amount of each variable from each of the monomials that are present. And then take all of your variables and the greatest common factor and squish them together, and you have your greatest common factor monomial. Here's an example. Let's find the greatest common factor of 12a plus 18a squared b squared. So first, in finding the greatest common factor of 12 and 18, which is equal to 6, reminder that if you're having difficulty finding the greatest common factor, you can do that in your calculator. In taking a look at both of the monomials in this polynomial, 12a and 18a squared b squared, we first take a look at the a. The first term has 1a, and the second term has 2 a's. Therefore, we're going to take one of the a's. We have another variable in b. The first term has 0 b's. The second term has 2. The least amount of 0 and 2 is 0. So I have the greatest common factor being 6 plus one of the a's, and that'll make my overall greatest common factor being 6a. Here's some examples for you to try. Pause the video at this point to give yourself a chance to try these on your own. Here are your answers. 4x plus 8y. They have no variables in common, but they do have a numerical greatest common factor between 4 and 8. So the greatest common factor of 4x and 8y would be 4. For the second one, we have a numerical greatest common factor of 7. They share 1a and 1b. So the greatest common factor, therefore, is 7ab. And finally, with the last one, the numerical greatest common factor between 25 and 36 is simply 1, so we don't need to include it. But they do share an a, a b, and a c. So therefore, your greatest common factor is a, b, c. Now in factoring out a GCF, just basically adds an extra step. I'll have an example to the right as I complete the problem with the steps on the left. The first thing I want to do is find the greatest common factor of all terms. In my example, we have 3xy and 18x. That gives me a greatest common factor of 3x. Next, divide both of the terms by the GCF. So I want to divide 3xy by 3x, and I get y. I'll divide 18x by 3x and get 6. Now I'm going to rewrite the problem, and this is called factoring out the GCF. I'll write the GCF, followed by opening a set of parentheses, writing my two quotients that I just got, and I'm watching my signs as I do that, and then I'll close the set of parentheses. So what I'm doing is I have 3x times the quantity, y plus 6. Here are some examples. Factor each of these binomials. Pause the video at this point to give yourself a chance to try them on your own. Here are your answers. The greatest common factor of 2a and 2b is 2. So I have 2 times the quantity, a plus b. In the second one, my greatest common factor is 8. So I'll factor that out, and I'm left with m plus n on the inside. Third one, b is my greatest common factor. So I factor it out. I'm left with x plus y. Let's try some harder examples. Factor each of these expressions. Pause the video at this point to give yourself a chance to try it on your own. Here are your answers. For the first one, we have a numerical GCF of 4, and they share an x. So I pull out a 4x, and I'm left with x to the 4th minus 6x squared plus 2. In the second one, I have a numerical GCF of 3, and they share 2 x's. So my GCF is 3x squared. After dividing it out, I'm left with 3x to the 4th plus 5x squared plus 4. And finally, the last one. My numerical GCF is a negative 6. They share 2 x's, so I'm left with negative 6x squared as my GCF. After dividing it out, I'm left with x squared plus 3x plus 2. If you're having any issues with any portion of this lesson, please make sure you are emailing me or consulting me in class.